Hi everyone, so for this I'm just going to talk over this PowerPoint slide and then talk over the worksheet that is part of the space introduction assignment. So our learning objectives for today: 1. Appreciate the size of the universe compared to Earth. 2. Understand how far our knowledge of the universe has come. So it is impossible for us to know everything about space. It is huge and we are tiny. So that's just to give you the idea of we don't know everything. This is still a very complex and open field. Most of science is open and complex and still has a lot to find out in it, but space is especially one of the most recent. And there are too many astronomers with theories about space to include here, but I've included basic overview of our understanding of space. You don't need to know the specifics, just read through these slides. It is useful to know how recent most of our advances are. So the first person I have is Aristotle. He was around from 384 to 323 BC, and he believed that all objects in the universe traveled around the Earth in circular orbits. So in his theory, the prime mover in the picture to the right moves all other objects in space around the Earth in perfect circles. So as you can see here, there's the Earth, there's everything else, the Moon, Mercury, Venus, and the Sun, all that within the prime mover. And the prime mover is just this giant force around the universe that moves everything around us. All they knew was that there was these planets around the Earth, and that was the entire universe that they knew of. So Ptolemy, he was around from about 100 to 170 AD. There were a few astronomers between him and Aristotle, but here's one that I'm focusing on. He was an Egyptian astronomer and mathematician, and he observed the pattern and brightness of stars traveling around the sky for over long periods of time. So that's why I have the star pattern here. So he would have seen this over long periods of time, just charting it out on a star map. Because of this, he added to Aristotle's theory, including epicycles and equants. So that's the equant, oh no, that's the epicycle, sorry. Just little rotations, little cycles that the other planets go through. And the equant is just a little distance off of the center. These geocentric models worked, but only because they forced the maths to work with it. And so this is a very clunky model. Too much is happening in it. The epicycles and equant makes everything messy. So if you look at this and look how complicated this is a lot more complicated than what we have. Aristotle's geocentric model was the accepted model with some revision. There were some deniers, but none changed public opinion until. And so with this, it was also against the church to suggest that anything was different. So anything went against that geocentric model. Geocentric means that the Earth is the center. Earth, geo, is central. Until 1,500 years later, roundabout, Copernicus was around. He was a Polish astronomer from 1473 to 1543 AD. And in his model, he hypothesized that the Sun was at the center of the universe. He still needed epicycles to explain his theory. He proposed this as a mathematical theory. If he had proposed it as science, it would have been called heresy, and heretical people were not treated very nicely. And so here's a little model of his theory. It's almost the same. There's fixed stars, all the planets travel around, but there's epicycles in there. And these models are called heliocentric, as the planets rotate around the Sun instead of the Earth. So Galileo was around in 1610 AD, and he was one of the first people to use a telescope to observe space. His observations are instrumental to our current belief of a solar system that travels around the Sun, but he himself still believed in the geocentric model. So what he did was he found a lot of evidence and he did a lot of observations, but he didn't use them to prove the heliocentric model. He instead believed in a geocentric model. There was then a Copernicus revolution. In 1543, the year of his death, Copernicus, that was unrelated by the way, as far as I know, Copernicus released his book about the heliocentric model of the universe. It took almost 100 years of other scientists finding proof of his theory for it to become the commonly accepted true theory. And his model is the basis of our current theories. At least he is the most commonly taught person to be the basis of our current theories. And that 100 years was the Copernicus revolution. And so getting a bit more recent now, the Andromeda Galaxy, Charles Messier, he was around from about 1730 to 1817 AD, first found the Andromeda Galaxy, but he didn't know what it was. He just sort of saw it, thought it was cool. In 1923 to 1929, which was about 200 years later, Hubble was able to prove that the Andromeda was that shape, Andromeda, was another galaxy outside of our Milky Way. And that's significant because Andromeda is our closest galaxy. It's featured in a lot of games and a lot of movies, but it's the closest one that we may be able to travel to at some point in the future, assuming that everything goes well. And so this was only a tiny overview of the history of our understanding of the universe. All these theories, if I included everyone in history, if I included all the details of their theories, it will take hours to research and read about. This PowerPoint would be much, much longer than it is now. So I just had to choose some people that gave us an overview of what the history of our universe as we understand it is. And our understanding of the universe is still changing. We are still discovering new planets, galaxies, stars, etc. Our current model of the universe is that there was a Big Bang billions of years ago, which produced everything of the universe, and as it's still expanding. Our solar system is a small part of the Milky Way galaxy. And that is all for this. I will move on to the worksheet and talk through that as well. Okay, so here is the worksheet for this. It has two parts to it. First part is two questions. Question 1, what is a heliocentric model of the universe? And part 2, question 2, who made the model that is the basis for our current model of the solar system? And then part 2, I'm asking you to go to this website, and where it has a little flash player, just scroll through to the right, watch through it. It's pretty interesting until you reach the largest objects. If the website doesn't work for you, I have attached a video to this assignment that is just me scrolling through the website for you. And then the question for this is to list 2 interesting or surprising size comparisons that you saw on the website. So one of mine was Asia is bigger in diameter than Mercury. So if you compare the size of all of Asia to the size of a planet in diameter, Asia is actually bigger, or they're both around about the same size, but Asia does look like it's a bit bigger. And so you just need to list 2 of your observations here, 2 things that you found surprising or interesting. Thank you. Hope you have a nice day.